EA, same as the XB and basic I showed you. Here's a command called EA load and run. So let's do this. Call EA. And let's use a program. I know a program right now on, I think it's on disk 9. Let's go back to disk 9. Whoops. And I think it is GPL dis. So let's do this. DSK9 period GPL dis as. I didn't pick the name. File is loaded. Press enter. And the name of the program is start. This is something else in RXB that you'll notice. Notice all these right here? You don't ever see those before, did you? RXB gives you a listing from what it's loaded. I've only seen a menu program do this before. I don't think anybody else has done that. Start. There's the program. So, showed you that. So that's EA load and run. EA program, basically the same thing. So if we go call EA PGM, and we have like disk 9 GPL at loader, which is my GPL loader on disk 9. There it goes. Anyways, that's that. EA program loader. The execute command, I showed you a demo of this. Basically what it is it takes the place of a call link. It goes directly to an address, and it uses this right here, assembly bracket program, to pull it off. Loaded into the fast RAM. Here's a little demo program I have here. And then it explains how it's put together and how you use it. And this explains how you use execute versus link also. Later on with demos, I'll be going full bore with each one of these as I go through by showing you demo programs. Right now I'm just doing a cursory to show you some things that I wanted to point out. Here's fcopy. Oops. Now, what we have here is a copy program that I wrote. And let's see now. Let's go back to a disk that we know has got nothing on it or very little. Let's take this all right here and delete it. So it's disk 2. So let's run this program. It uses a command called fcopy. Now, fcopy asks for a path name, a file name, then a path name and a file name. So master and then copy, and then our file name. What you can do with this, interestingly, is change the file name. So if you want to copy a file, it'll change the file name. So if you have you could change the file name in it to be something different when it does the copy. I think you can do a maximum of, fcopy can copy up to 12 files from 12 drives to 12 drives to 12 different file names at one command. So you can do up to 12 at once. Now there is a cost for this. It does have a cost, and it's right here. 4K of VDP must be available to use it, or you have a stack overflow. The reason why is because fcopy uses 4K of VDP memory. And if that 4K is not there, then fcopy will just overflow or not enough memory. One of the two. Very full. So you have to allow for this size. You had to have some place to put the buffer. There's just, nothing's for free. So that's one of the costs. By the way, bload and bsave use 8K of VDP memory. So those are best if you use those with the AMS card. The reason why is because you bload all your stuff into the AMS card, run the next program, and you never have to worry about, you can use the full size of the program in Extended Basic and the AMS at the same time and never have to bload again. Much easier to do. Anyways, let's run fcopy. Oops. Now it's asking for a master path. So let's go with 9. because we know what's on 9. And let's go disk 2. Shows you the file it's copying, and there's the file being copied. Mind you, that's not too bad considering it's running from Extended Basic of all things. And some of these files are, well, this is 1 kilobyte. Let's go back. What does it say 1 kilobyte? Oops. Well, that's interesting. I've never had that happen before. It copied all of them. Ooh, something went wrong. I wonder if it was a program I was running before that caused the problem. Well, this is bad. Destroys my video. Well, sometimes you bite the dog, sometimes the dog bites you. Fcopy apparently doesn't work. I got it to work the other day, and it hasn't worked since. So something's gone wrong. It works on regular TIs. I just tested it on PC99. It does work. But with Classic, sometimes I have some problems, especially when it's accessing disk. And Classic isn't designed for that. That's just the way things are. So here's the call files. I've updated that. You can do a call files 15 in RXB. See that? 5624. Normally the most you can do, I think, is 9 on a regular disk controller. That's the most it allows you for. Why you want to do 15, I wouldn't know, but I've allowed for it. Also, when you do a call files, it automatically does a new afterwards. So that's a bit different than normal. See, normally you have to type in new by yourself. So RXB added the new. Get character. I've showed you a demo of what that does. It's just added the, you can keep going. Get motions, the same way I've done a demo of that. Let's see now, what's the next demo? Crash. Oh, how about if we jump down to this? Hex. Okay, now what have we done here? I want to show you an interesting aspect of what you can do with memory that made a lot of sense to me. Normally when you make a data statement, these are your numbers you're going to put in. And everybody's seen this. You put in numbers in a data statement, and then you take the numbers and you punch them in, and they take up so much memory. Now, the problem with this is that if you see up here, normally that took 128 bytes of memory to store all these numbers. 128 bytes. Now, what if we do this? We take the number, read it, we turn it into a hexadecimal digit, and then hexadecimal digit is going to be taking just 2 characters from it and put it into a string. Now, it sounds big because it's 2 characters, but these take actually more space. This takes 8 bytes each. To store a number like this is 8 bytes. 8, 16, 24, 32. It adds up quickly to 128. Now, if what we do is we take 2 characters in a string, you know, we have the string length and that, what we're going to get is going to use 35 bytes. 34 for the actual storage, and 1 for the string length. So we've saved 93 bytes. So let's look at the string. We've taken this and turned it into this. Now it even looks smaller than this does, because these numbers right here just go off the screen, and this does too, but only by this much. We actually add an extra character here. We don't need these 2 right here. So essentially what we've done is we've taken memory and we've saved memory by doing it this way right here and putting it in a string. Also, as in a string, when you go to load it, I can use a call moves string that I showed before. from a string variable into another string variable, or we can go into VDP memory, or we can move it into RAM, or we can move it into ROM if we have a GPL device. But the point is, you can take that string and move it into memory, and it's much more efficient than the numbers are. It's just one of the things, ideas that I got, and I wanted to show you. So that was hex. We've already done that. Next we have crash. Sorry, it's 4:10 in the morning. So there's hex, or hget. This just gets a list of characters off the screen. So essentially what it does is, like, you could grab a bunch of characters off the screen, put them in a string variable. Many people have demoed something like this. There's call honk. Same sound. Hput, which puts a string on the screen. I've already demoed that. Init, I've already demoed that too. Call init. RXB is a little bit different when it shows memory space. Inverse, I've already shown that. Oops. Let's do all the characters. And they're inversed. Everything's been reversed in the field. We can turn it back. It's back to normal. All right, anyways, let's try this. Let's go to the next one here. Well, we can inverse a single character. I'm going to show you this. Call inverse. We're going to do 30, the cursor. There we go. Cursor's been changed.